So the cycle of rock starts in the lower part of the Earth's crusts in a depth of 20 to 50 kilometers. In those depths, the rock temperature will be between 1,200 and 1,400 degrees centigrade. The rock will be molten, and if parts of the rock will be uplifted, it is going to be cooling down very slowly over thousands and millions of years. And the internal structure of the rock will be generated by the first minerals that are falling out. The rock is called, the hard rock that's been generated is called magmatite. And we know these rocks, which are somehow called granites, which may be uplifted by plate tectonic and orogenic processes, even coming to the surface. And when this rock has reached the surface, it's going to be weathered by atmospheric influxes. And the atmospheric influxes, like rainfall or snowfall or temperature variations, will erase erosion and sedimentation processes. So part of the rock will be transported with rivers to the sea, and at the seashore it will be sedimented as sand and as a mixture of sand and limestone, for instance. The limestone are chemical sediments that are deriving from organic structures like reefs in the close area of the shores. However, more and more sediments will arrive and will overburden the existing sediments, and those sediments will be covered by others with several kilometers of overburden. And now the former non-consolidated rock will become a consolidated sedimentary rock, even going down and partly being reorganized internally. So the minerals will get a new position, and this rock structure, the new rock structure, which underwent this process of the so-called diagenesis, is now called a metamorphic rock. The metamorphic rock is not molten yet. There may be some molten parts, but it's not molten yet. And it may also be uplifted by new tectonic processes and may even reach the surface and may even undergo the same fate as the magmatic rock in advance. It will be eroded, it will be transported and deposited in lake shores or seashores, and it will become part of the sedimentary cycle. However, if these rocks will even go further down and will be heated up to these temperatures of 1,400, 1,500 degrees C, it is going to be molten up, and the magmatic cycle will start again. Part of this magma may also rise up towards the so-called magmatic chambers. And those magmatic chambers, filled with molten rock, may serve as the source for volcanic rocks. So very fast, these rocks will reach the surface and are still molten and may build up those volcanites, and the volcanic rocks will also, being weathered, will also be deposited or transported, eroded, and finally sedimented and become part of the whole sedimentation and cyclic rock process. So all these three pillars, the magmatic rock, the sedimentary and metamorphic rocks, and the volcanic rocks, are part of the cycle of rocks. In general, the temperature is going to rise towards towards depth with an amount of 30 to 40 degrees C per kilometer. For the geothermal interpretation, it's crucial to understand the cycle, the geological cycle, because it's not only the temperature, it's also the fracture zones, and it's also the pathways for hydrothermal waters that will flow through these different types of rocks, that will interact with the rock, that will change their chemistry and may influence the whole subsurface system and the whole hydrothermal or petrothermal system for the geothermal application.